Alrighty, so what I'm going to do is explain these four calculations for temperature conversions. And just as a reminder, I've put up here your formulas for the conversion between Kelvin and Celsius. So TK, which is the temperature in Kelvin, those are your units, equals the temperature in Celsius plus 273. I also gave you the temperature in Fahrenheit equals 1.8 times your temperature in Celsius plus 32. Now what you need to remember for this is that the 273, the 1.8, and your 32 are exact numbers. Alright, and the way that that impacts your calculations, since they are exact, we consider their number of significant figures to be indefinite, and therefore we ignore the number of significant figures for these guys. So what you're going to be looking at for decimal places or for significant figures is going to be just the temperatures that are given to you. Alright, so you'll see how that pans out in these problems. So for the first problem, I give you 218 degrees Fahrenheit, and I want you to convert to Celsius. So you're going to be using this bottom formula, and if you notice, when we start rounding, we need to be considering significant figures, so just keep that in mind. So I've got my TF, my temperature in Fahrenheit, equals 1.8 times my temperature in Celsius plus 32. I plug in my 218 here because that's my temperature in Fahrenheit. I set that equal to 1.8 times my temperature in Celsius plus 32. Now this is just going to be an algebraic equation now, so I got to subtract 32 from both sides. I get 186 equals 1.8 times my temperature in Celsius. So to get TC, temperature in Celsius, isolated, to get it by itself, I just need to divide by 1.8. Alright, and what I get unrounded is 103.33. What you notice, since I'm dealing with significant figures for this conversion, this has 3 sig figs. Now don't let this trick you, because this is 2 sig figs, this is 2 sig figs. Ignore that, because those are exact values. Instead, all you're having to be concerned about is what's given to you. So this is 3 significant figures, so your final answer needs 3 significant figures as well. So I have 1, 2, 3, I end up with this 3. And so it rounds down because this 3 here directly to the right is less than 5, and so I end up just with 103 degrees Celsius. Notice I dealt with my significant figures, I dealt with rounding, and I included my units. For the next problem, you're going from Celsius to Kelvin, and so I'm going to be using this formula, so I'm dealing with decimal places. So I put in my formula. My temperature in degrees Celsius is 25, so I plug in the 25 here for my temperature in Celsius. I add them together and I get 298 Kelvin. Notice there are no degrees Kelvin, we just write Kelvin, so be careful with that. The other thing is that I'm not dealing with significant figures, so don't round your final answer so that it only has 2 sig figs, because I'm not dealing with sig figs. Since I'm just adding, I'm dealing with decimal places. So it rounds, since 25 has no decimal places. Remember, a decimal place is the number of places after the decimal to the right of the decimal. Since I don't have any decimal places here, I should not have any here, and I don't. For number 3, it gets a little bit more tricky because it's going to be a two-step problem. I know the relationship between Kelvin and Celsius. I know the relationship between Celsius and Fahrenheit, but there isn't a conversion that I've provided you with, or a formula to convert between Kelvin and Fahrenheit. So first I'm going to have to go from Kelvin to Celsius and then to Fahrenheit. And so I do that in this problem. I first have my formula for Kelvin and Celsius conversion. I know that I have 77 Kelvin, and so I subtract both sides, from both sides 273, and for my degrees Celsius I end up with negative 196 degrees Celsius. You should be checking your rounding. Remember, don't round. If I needed this to be 1 sig fig, don't round to negative 200 yet until the very end. But let's just make sure that this is correctly rounded. Because I am dealing with Kelvin to Celsius conversion, I should be looking at decimal places. And so 77 has no decimal places, negative 196 has no decimal places, so I'm good to go. I then need to plug in my degrees Celsius, that measurement in degrees Celsius, into my Fahrenheit Celsius conversion formula. And so I plug it in here for my temperature in Celsius, and I do the math. 1.8 times negative 196 plus 32, and I get negative 320.8 degrees Fahrenheit. Now for rounding, because I'm now dealing with my Fahrenheit to Celsius conversion, I need to be looking at significant figures. This is 3 sig figs. this has 3 sig, well, this has 4 right now, and so I need to round this to 3 sig figs, so I get negative 321 degrees Fahrenheit. For number 4, 98.6 degrees Fahrenheit, that's actually your body's normal temperature. For the most part, most people have about 98.6, and I'm trying to convert that into Kelvin. And so what I'm going to do first is, because I don't have a direct equation for going from Fahrenheit to Kelvin, I'm first going to go to Celsius. And so I plug in the 98.6 to my temperature in Fahrenheit, equals 1.8 times my temperature in Celsius plus 32. So I solve for TC by subtracting 32 from each side, dividing by 1.8, and I get 37.0. Now the reason why I put 37.0, since I'm doing my Fahrenheit to Celsius conversion, I need to be looking at significant figures. 98.6 is 3 sig figs, therefore this answer has 3 sig figs as well, 37.0 degrees Celsius. I don't want to stay in Celsius, I want to get into Kelvin, and so I'm going to plug my degrees Celsius, my temperature in Celsius, in here, add 273 to that. Now, since I'm going from Kelvin to Celsius, well, from Celsius to Kelvin in this case, I look at decimal places. Since 37.0, which is correctly rounded, has 1 decimal place, 1 place after to the right of the decimal, my final answer needs to have 1 decimal place. Remember, 273 is exact, and therefore I'm not going to be using 273 to determine decimal places. And so I need 1 decimal place, so when I get my answer 310, I have to add a 0.0 to hold for that 1 decimal place, and my units are Kelvin, not degrees Kelvin, and that's it.